Alright guys, welcome to our channel. So if you're new, please subscribe for more tutorial video like this one. And this time let's talk about the integral of exponential and logarithmic function. So here are the four important rules for in terms of integrating exponential and logarithmic function. Number one is what we have here. So that's whenever we try to integrate a function that has this form which has a du over u. So u represents any functions, or it could be a variable that just equals to ln u, and then never forget plus c. So basically this rule is part of the basic integration rule, but I put that here because the answer has a natural logarithmic function. So that's just for me to avoid confusion. So let's go to rule number 2, which is this one. Whenever we have an exponential function which is raised to some term or a function u and then du, that's just equal to e raised to that function u plus c. So basically, as you can see, it never changes, but it could change the whole number right here depending on u. So we can see that after we try to answer some of the examples. And then number 3, whenever we have to integrate a, where a right here is a constant, or it could be any real number, and then that is raised to some function or some term u, and then du, that's just equals to the constant or the whole number raised to the power of that u right here, and then over the natural logarithmic of that constant or real number, and then never forget plus c. So the last one is this one. Whenever we try to integrate a natural logarithmic function, this is basically ln, and then we have some term or some function u, and then we have our differential du, that's just equals to, we have u ln, and then the absolute value of u, and then minus u plus c. So that's it guys for the rules of in terms of integrating exponential and logarithmic function. Let's go directly to some of the examples to understand the topic even more clearly. Okay, so let's go to example number 1. So basically, you can pause the video and answer this on your own, and let's just see how it works. Let's go answering the example number 1. That would be the integration of dx over e and raised to the term which is 3x. So the first thing that we need to do right now is that basically we could raise this denominator to the numerator. So that would become the integration of we're going to have, since we're going to raise that, we have to change the exponent, the sign of the exponent. So we have positive. So when we raise that to the numerator, that would become negative 3x, and then never forget dx. So therefore, the next thing that we need to do in order to match up, so what we have here is the rule number 2, is that we need to find the value of u. So what is the value of u for this one? So let u is equal to, since we have right here, that would be negative 3x. Let's put negative 3x. And basically guys, what we're doing right here is just equal to or the same when we try to integrate using u substitution. So there is a previous video that I've already done right there, and you can check that one. That is very useful through here, and because we are going to use that. And next time is we need to of course integrate du in terms of x, since our variable is x, and it would become negative 3. And then of course we need to find the value of dx, which is just equal to du over negative 3, right? So this is equal to du over negative 3. We only need to of course multiply this one. So we already have the value of u and dx. Let's go and substituting that one through here. That would become equals to integration of e, our negative 3x is u, our dx is equal to du over negative 3. Since we have a whole number which is 1 over negative 3, we can factor that out through here, and then that would become equals to negative 1/3, since we have negative, and then leaving behind an integration of eu du. So notice that this one is just equal to our rule number 2 right here. So let's continue. So what is the integration for this one? That would become negative 1/3. And then the integration of e raised to some function of u is just equals to e some function of u, and then never forget plus c. So therefore, substituting the value of u, we have 1/3, and in e, what is our u? Our u is just right here, negative 3x, and then plus c. So therefore, this would be our answer, but we can basically rewrite this 1. We are going to have negative 1 all over 3, because since we have a negative symbol of exponent right here, we can bring down back to the denominator. So therefore, from negative, that would become positive 3x plus c. So either way, this one is the final answer, and this one also is the final answer depending on your professor, but the two are correct. So we're already done with number 1. Let's go to number 2. So let's go answering this one. That would be equals to. So basically this has a constant or whole number right here, or real number, which is raised to some function which is 4 minus 3x. So how do we try to integrate that one? Basically, if you try to look back at this one, it basically suits to number 3 or rule number 3. So let's use that one, rule number 3. Therefore, rule number 3, let's just put it here. We have AU is just equals to AU over the logarithmic of A plus C. So since we have our A, which is 5, let's just put A is equals to 5, and our U is equals to the exponent, which is this function, that would become 4 minus 3x. And then using integration by use substitution, we can integrate du over dx, and then integrating each of the term, the integration of constant is just 0, and then negative, the integration of 3x is 3. So therefore, du over dx is equals to negative 3. And then we need to find the value of dx. Dx is just equal to du over negative 3. So basically this is equal to what we have here in example number 1. So since we already have the value of a, we have the value of u, and we have the value of dx, we can now substitute these to the original integration form. So let's go to second process, that is equals to integration of our 5 is a. Basically you can just directly put 5, but just for me, I'm going to put a to avoid confusion. And then 4 minus 3x is our value of u, since what we have here. And then dx is du over negative 3. So we can basically factor out that 1 over negative 3. That would be like this, and then leaving behind au and then du. So notice this one is just equals to what we have here. So this is easy to integrate right now. So therefore, we are going to have equals negative 1/3. And then the integration of this one is just equal to, let's multiply that, au over ln, and then a plus c. So therefore, this is plus c right here. So therefore, we can now substitute the value of a and u. We have going to have negative 1/3 multiplied by our a is 5, our u is 4 minus 3x, and we have going to have ln, our a is 5, and then plus c rather. So we can simplify this further. 1, that would be negative 1 times 5 raised to 4 minus 3x, would just equals to 5 raised to 4 minus 3x, and then all over, that is negative, we can put this one right here, all over 3 ln 5. So basically you can simplify this one further, but just for me, I'm going to put it that way, and then never forget plus c. So this would be the final answer for example number 2. So let's go to example number 3 and 4. Example number 3, let's go answering this one. So this just equals to integrating each of the term, that would become, since the whole number is 5, we can factor that out. That's just equals to 1 over x3. And then answering that directly, basically we can raise x cubed right here to the numerator, so that would become x negative 3. Since this is positive 3, that would become negative 3. and then plus integrating, we have a whole number which is 3. We can factor that out, leaving behind 1 over x dx. And never forget dx in this form. So integrating each of the term, that will become 5. How do we integrate this x raised to negative 3? Using the power rule. So that just equals to x, let's multiply that 1. Negative 3 plus 1 is as negative 2. This is over negative 2. And then plus 3 times, what is the integration of 1 over x? So basically 1 over x is just ln and then x plus c. So because this is based on our rule number 1 right here, that is du over u, or 1 over u, or 1 over x, and then dx. This is, both are the same. So let's continue. Let's simplify this one. That just equals to, we have 5 over negative 2, and then since we have negative sign in the exponent right here, we can go bring that back down to the numerator, denominator. That will become x raised to 2. So that would be it, and then plus 3 ln, and then the absolute value of x plus c. So this would be our final answer for example number 3. Let's go answering the example number 4. So this one, we have to integrate the exponential function ex minus 4 e raised to negative x, and then over negative, e raised to some function of x or term x. So as we can see right here, this is quite complicated, but basically if you know the trick of algebra, basically it's just easy to answer. So we can find the equivalent function right here. So we can use this one. Since we have the same denominator, we can put this one either way, ax over ex, and then minus 4e negative x over ex, right? So we can basically put it this way because the function are equal. So therefore we are going to have e, since they are the same, that's just equal to 1, and then minus 4e, that's 4, sorry, 4e negative x over e negative, ax. And then we have to simplify. Never forget dx rather. That's important. Dx. Let's go. We can basically simplify this one, right? That will become, we have to integrate, we have 1 right here, and then integration of dx minus 4 integration of this one. We have e raised to negative x divided by e raised to x. So basically we can let's put it here, e over, raised to negative x e. So this is equals to e, and then we have to minus or subtract the exponent. So we have negative x minus x, so this just equals to negative 2x. So therefore this will become e raised to negative 2x. That will become right here, e raised to negative 2x, and never forget dx. So integrating, so the integration of this one just as x minus 4. So basically we can put let u is equals to negative 2x first, and then we have to derive that d over dx equals to negative 2, and we need to find dx equals to du over negative 2. So therefore, since we already have the value of u, which is this one, and we have the value of dx, so we can now substitute this to this term. That would become integration of e, our negative 2x is u, our dx is du over negative 2. So we can factor out that negative 2. So this will become x minus 4. So since we are going to factor negative 1/2, that would become leaving behind integration of eu du. So simplifying even more further, we're going to have x. This will become positive 2 because negative 4 multiplied by negative 1/2 is just they have the same integer, which is negative, that will become positive, and then 4 divided by 2 is just 2. And then what is the integration of this form? So going back to our rules, that is rule number 2 what we have here. So the integration of eu du is just equals to it's multiplied EU and then plus C. So since we already have that, we can now substitute the value of original U. That will become x plus 2 E. What is our value of U is negative 2x and then plus C. So therefore, this would be our final answer for this problem, which is example number 4 rather. Okay, so that's it for example number 3 and 4, or problem number 3 and 4. Let's go to our last two examples, which is the example number 5 and example number 6, or problem number 5 and problem number 6. So let's go answering the problem number 5. So we are going to have integrating the 4 raised to x and then multiplied by 5 raised to x and then dx. So basically, some of the students are quite finding this quite difficult, but if you are already, if you remember the law of indices in algebra 1, so whenever we have a integer right here that is raised to some exponent m multiplied by another integer or whole number and then raised to the same exponent m, that's just equals to a multiplied by b and then raised to m. So therefore, we have a different whole number but raised to the same exponent. That's just equals to the integration of 4 multiplied by 5. That represents multiplication and then raised to x dx. So therefore, this will become integration of 20 raised to x dx. So we can now evaluate the integration for this one. So this is quite the same to the rule number 3. So let's go back to the rules. So as we can see right here, we have a u du, which is a constant. So our constant in problem number 5, or integer in problem number 5, is 20. So the first thing that we need to do is So the first thing that we need to do is we're going to find the value of a, that's 20, and then of course our u is just x, and then we need to find the value of we need to derive the u. That would be d over dx equals to the derivation of x is just 1, and then finding the value of dx, let's put it this here, dx is just equals to du over 1, or just equals to du. So since we already have all the values for this, we can now substitute this through here. 20 is our a, so basically you can put directly 20, but for me I'm going to put a to avoid confusion. X is u, and then dx is just du. So we can now find an integration for this one, since rule number 3 talks about whenever we try to integrate this is just equals to au over ln a and then plus c. So therefore, this is just what we have here. That would become au over ln a plus c, and then substituting all the values, that would become a is equals to 20, our u is x right here, and then over ln 20 plus c. So therefore, this would be our final answer for problem or example number 5. So let's go and answering number 6, our last problem. So let's put equals right here. So since we have two terms that is separated by addition right here, we can now evaluate each term. That would become integration of e raised to 5x plus the integration of ln and x. Never forget dx. That is very useful whenever we have an integration symbol. So let's go and integrating this. So first thing, we have e raised to 5x. So therefore, in the first term, we can let u is equals to 5x, and in deriving that u, it become du over dx, that will become 5. Since the integration of derivative of 5x is just 5, and then going to find the dx is just equals to du over 5. Therefore, we can now substitute the value. We have eu, which is our dx for the first term, that would be du over 5, and then plus right here, since as you can see in the rules, our last rule rather, which is here the fourth rule, that is ln u du. So we have ln x in the last example, in the last term, that will become ln, let's put in the first term right here, and the second term, u is equals to x, so du over dx equals to 1, so basically dx is just equals to du, so that become ln u, and then dx is du, this is du. So let's go on simplifying. Since we have 1 over 5 right here, we can factor that out, leaving behind eu du, and then plus copying the second term ln u du. So we can now evaluate the integration for this one. So that will become 1 5, and then the integration of integration of eu du is just equals to eu, and then plus, that's plus, and then the integration of ln u du is equals to what we have here in the fourth rule, that is u ln u minus u plus c. Wow, that's long. That would be plus u ln u minus u plus c. So we can now substitute the value of u, that's 1 5, eu, u in the first term is what we have here, that is 5x, plus our u for the second term is just x, that will become ln x minus x plus c. So therefore this would be our final answer for the last example or the last problem. So that's it guys, thank you for watching, and I hope you learned something from this video and study well. And then if you have some question, you can comment down below and I will try to find a time to answer that right away. So thank you so much for watching, and God bless.